Following data preparation, we will perform data transformation. Data transformation is the data conversion process that transforms the data from one format or structure to another. There are usually two goals that we are trying to achieve in data transformation. One is to meet the statistical or data mining techniques requirements. For example, some techniques would require you to use numeric data for the analysis, while other techniques would require you to use categorical data for the analysis. So being able to transform data from numeric to categorical or from categorical to numeric would be important. The second goal we are trying to achieve through data transformation is to enrich the data by bringing information out of data, sometimes by combining different variables together using some kind of mathematical transformation will allow us to create new variables that might help to bring the information out of the data. First, let's talk about how we can transform numeric data. When transforming numeric data, there are three key techniques that we are going to discuss. First is binning. The second is using mathematical transformation to create new variables. And the third, converting date values to numerical values in order to enable calculation and comparison. Let's first talk about binning. Binning is the process of transforming numeric variables into categorical variables by grouping the numeric variables into a small number of groups or bins. For example, age is a numeric variable. We can create bins for age in order to convert age into a categorical variable. For example, we can create a bin for people who are younger than 25 years old. Then create another bin for people who are 25 years old or greater than 25 years old, but less than 50 years old. And we can create another bin for people who are greater than or equal to 50 years old. As you can see, bins are usually consecutive and non-overlapping. And it's important to create labels for these bins or groups in order to differentiate them from each other. Binning is a technique that's often used to help us transform numeric variables into categorical variables in order to meet the needs of the analytics technique. But also at the same time, binning can help us reduce noise in the data. There are three primary binning techniques: user-defined boundaries, equal intervals, and equal counts. If you're using user-defined boundaries, the users will define what the boundaries of the bins are. For example, we can create bins for the income variable by having a bin of people making less than $50,000 a year, another bin for people who make $50,000 a year or more than $50,000 a year, but less than $100,000 a year. And then we will create another bin for people who make $100,000 a year or more. As you can see, the boundaries are defined by the users. We can also create equal interval bins. For example, we can create bins that each represents 10 degrees in temperature change. All bins will have the same intervals in this case. We can also create bins that have equal counts, which has the same number of observations in each bin. In this example, we are going to transform numeric data using the binning technique to create RFM scores. RFM score is a common technique used by companies to assign a value to each customer based on their past purchase. RFM stands for recency, frequency, and monetary values. In our data set of the customers of Organic Food Superstore, we have data related to when their last purchase was, the number of orders they placed in the past, and how much they spent in 2018. And we can use these variables to create an RFM score for each one of these customers. A common practice for creating RFM score is to create bins of equal counts. In this case, we are going to create RFM scores by binning the variables days since last, number of orders, and spending 2018 into 5 equal count bins. And then we are also going to bin the income variable into 5 equal interval bins. And finally, we are also going to create a tiered membership status based on the customer's 2018 spending. In this demonstration, I'm going to show you how to perform RFM analysis using R using the binning strategy. As I mentioned earlier, the RFM analysis is a popular marketing technique used to identify high-value customers. RFM stands for recency, frequency, and monetary value. Using the customer's dataset, we can use the days since last variable to find out the recency, using number of orders variable to find out frequency, and the customer spending in 2018 to find out the monetary value for the customer. So this is how RFM analysis works. Following the 80-20 business rule, which means 80% of your business comes from 20% of your best customers. For each of the 3 RFM variables, we are going to bin customers into 5 equal size groups, with 20% of the customers included in each group. Each group is also assigned a score from 1 to 5, with 5 being the highest. So customers with the RFM rating of 555 are considered the most valuable customers to the company. And likewise, customers with the RFM rating of 111 are considered the least valuable customers to the company. As you can see, I have already imported the customer's dataset as the MyData data frame in R. To create the recency score, we first transform the variable days since last to reverse the order of the data, because the fewer the number of days since the last purchase, the greater the recency score. So let's create a new variable called the days since last reverse by multiplying days since last by -1. And we need to use the as.numeric function to ensure that the days since last reverse variable is a numeric variable type. So I'm going to start a new script by going to File, New File, R script. I'm going to create a new variable in MyData data frame, and I'm going to call it days since last reverse. Using the as.numeric function, and then multiply the days since last variable by -1. And run it. Now we are going to create 5 equal-sized bins for days since last reverse for recency score, number of orders for frequency score, and spending of 2018 for the monetary value score. As the bins represent the 20%, 40%, 60%, 80%, and 100% quantiles, we first use the quantile function to find the range for each bin and store the ranges in an object called the recency bins. We are going to use the props parameter to specify the size of each bin, which is 20%. And we're going to use the sequence function to define the 20% intervals, going from 0 to 1 with an interval of 20%. We're going to run this line of code, and then let's take a look at the range for each bin. As you can see from the result, here's the range for each bins. For days since last reverse variable, the first 20% of the cases are between negative 360 to negative 294.2, and the second 20% are between negative 294.2 and negative 218.4, and so on. And we can do the same thing for the number of orders and the spending in 2018 to create the frequency ranges and the monetary value ranges. Note that if we were to create 10 equal-sized bins, we would change the props option to props equal to sequence 0, 1, by 0.10. Let's run these two lines of code. If you want to take a look at the ranges, we can type in the names of these bin ranges. For example, frequency bins. As you can see from the result, the frequency bins boundaries are 1, 4, 7, 11, 16, and 31 orders. Same thing for monetary bins. The ranges are 50, 300, 552.6, 765.2, 1044.4, and 1250. Now that we have the ranges for the bins, we are going to use the cut function to bin the data. In the cut function, the breaks option will specify the ranges of the bins created in the previous step, and the labels option will assign a label to each bin. We are also going to include the option right equal to false to ensure that the intervals are closed on the left and open on the right. And we are going to use the include dot lowest equal to true option along with the right equal to false option, so that the largest value is included in the last bin. I'm going to create a new variable called a recency using the cut function. to cut the days since last reverse into multiple bins based on our boundaries for the bins created in the previous step. And I'm going to label each bin using the labels option. And each bin is labeled with a number from 1 to 5. Make sure to include the include.lowest option and the right equal to false option. Let's run this to make sure that there is no error. And we are going to do the same thing for the frequency and the monetary value. To save some time, I'm going to copy this line of code and paste them here and make some changes to my code. I'm going to create a new variable called the frequency to store the frequency score for the customer. And it's going to bin the data based on the number of orders using the boundaries that we created earlier for frequency. And also I'm going to label them using the numbers 1 through 5. And lastly, I'm going to create the score for monetary value. And create the bins based on the customer spending in 2018. Using the bin boundaries that we created earlier for monetary values. I'm going to run these two lines of code and make sure there is no error. Okay. Now we are ready to create the IFM score for the customers. We are going to combine the score for recency, frequency, and the monetary value using the paste function in R. And then I'm going to take a look at the first few observations to see if we have done this successfully. I'm going to create a new variable in the myData data frame called RFM and use the paste function. The paste function in R is going to help you combine a number of fields together. In this case, I'm going to combine the recency field that we just created, the frequency field, and the monetary value field. Let's run this, and then let's take a look at the first few observations using the head function. Okay, as you can see from the result, it's showing us the IFM score for the first 6 records. The first customer has an IFM score of 411. The second one has an IFM score of 244. So what this means is the first customer purchased from us relatively recently. However, the customer purchased pretty infrequently and also spent relatively less amount of money on his or her order. Next, we are going to bin the income variables into 5 groups with equal intervals using the cut function. To create the equal intervals, we only need to specify the number of bins in the break option in the cut function. And we are going to assign numbers 1 to 5 to the bins, using 1 as the lowest income and the 5 as the highest income. So I'm going to create a new variable in my data frame called the binned income. And I'm going to use the cut function to cut the income variable and create 5 equal interval bins. And label them using numbers 1 through 5. Also make sure that you include the lowest option as well as the right equal to false option. Now let's run this. Make sure there is no error messages. And then let's take a look at the binned income variable for the first few observations. As you can see from the results that the first few observations have the binned income values of 1, 3, 2, 2, 1, 2, which means the first customer is in the lowest income level and the second customer is in the third income level, and so on. And if you are interested in finding out the ranges of the 5 intervals created in the previous step, we can use the levels and the cut functions to find that out. As you can see, these are the boundaries of the 5 equal interval bins for the income variable. So the first range is 30,900 up to and including 58,200. If you want to find out the number of observations that belong to each of these bins, we can use the table function. As you can see, the table function shows you the frequency for each bin. So in the first bin, with the lowest income, there are 67 observations. In the fifth bin, with the highest income, there are 3 observations. Now we are going to create the membership tiers using user-defined bins, and we are going to again use the cut function. This is the rule we are going to use to create the membership tiers. For customers who spend less than $250, we are going to assign them to the bronze membership. For those who spend $250 or more, but less than $1,000, we're going to assign them to the silver membership. And for those who spend $1,000 or more, we are going to assign them to the gold membership. In this case, we're going to use the break option in the cut function to specify the user-defined ranges. So I'm going to create a new variable called the membership tier in the myData data frame. And I'm going to use the cut function to bin the data based on the customer spending in 2018. For the range boundaries, I'm going to use the user-defined boundaries to define the three bins. The first bin is from 0 to 250, and the second bin is from 250 to 1000, and the last bin is equal to 1000 or above. So for the last bin's boundary, I'm going to use the number infinity. And I'm going to label them using the different membership tiers: bronze, silver, and gold. Okay, let's run this line of code. Now let's take a look at the membership tiers. As you can see, the result shows the membership tiers for the first 6 observations. The first customer belongs to the bronze membership, and the rest of the 5 customers all belong to the silver membership tier. If you want to find out how many customers are in the bronze, silver, or gold membership tiers, you can again use the table function. As you can see, there are 35 customers in the bronze tier, 118 in the silver tier, and 47 in the gold tier. So to summarize what we did, we first created the RFM score to assign a value for each customer. To create the RFM score, we used the equal size bins, and then we bin the income variables into 5 groups with equal intervals. And finally, we assigned each customer into a membership tier based on their spending in 2018 using user-defined bin ranges.